I wanted to take a minute to show off what I've been working on for the past couple of weeks. What started off as an attempt to innocently revamp my cross-platform 2D PS Vita renderer turned into a little bit bigger of a project than I anticipated. So real quick, I'll cover on what I did for the Vita. So with the Vita now, I have upgraded the renderer to be a three-dimensional first renderer. It's still going to be capable of 2 dimensions. You're still going to be able to use an orthographic projection matrix. You're still going to be able to draw quads. But I've created this sort of object-oriented style C structure here. It's essentially a giant V table. And the reason I did this is because I wanted to write all of the code for the back end, like the renderers and stuff like that, in C. And so now I've created a little test project to really stress it. I should also add that this VGL 3D context structure here that I've created, this is not just limited to a Vita GL or OpenGL 2 ES renderer. I actually created a metal renderer too. So I had to create a custom library called Mul. I call it Mul because it's the metal utility library. And then I've got all the functions overloaded with VGL 3D metal functions. Not all of them are implemented yet, but so yeah, we've got a metal renderer and a GL2 ES renderer and Mul that have come out of this so far. So that's like 3 big projects. And the nice thing about VGL 3D is that it provides you a consistent interface for rendering. Now, I took that and expanded upon that and created this little, I'm going to call it a demo application, really just to showcase like the power of everything here. So obviously you're familiar with IMGUI, I'm sure. IMGUI is what's driving my interface right now. So this is essentially like a little mini Unity. So we've got a scene root. As you can see here, I've got some of the standard objects. So we've got an ambient light and we've got the scene camera. So if I go to the scene camera and I manipulate it, you can see obviously it updates in real time just like Unity would. So yeah, there's that. Pretty sweet. Camera field of view obviously works. You can change the clear color if you're not a fan of that, but I'm going to leave it as is. And you can change between these different camera types, but Metal doesn't have this implemented yet, so for now it's just all that. So obviously, as you can see, like there's some polymorphism going on. This example application was written in C++, so I'm taking advantage of C++ classes and polymorphism. So there's a lot of standard properties here that are consistent across all entities. And then there's the extra light properties that are added after. All right, so here's the ambient lighting, and you can change the color of that if you want to. Where it gets more interesting is if we go to this test point light here. And as you can see, I can adjust color and intensity of this. Let's say we want a purple light. Purple lights are cool. Now, I've obviously still got some math to work out, but as you can see, this is indeed, lower that a little bit, this is indeed diffuse lighting. So as I move the light around, you'll see more faces get lit or not lit. Pretty cool if you ask me. Okay, so I'm not a fan of this cube. Let me change this cube. So I'm going to select my cube entity, and I'm going to change its mesh to one of these that I have in a list. Let's do this one. Okay, so now we've got the default Blender monkey in rendering. So I'm going to go ahead and adjust the rotation so that you can see the face. You can see we got some artifacts there from the rendering. I don't have cull functions fully set up yet. But now if I go ahead and take this point light, I can move it around some more. You can see the monkey's face changes. The monkey is a really good showcase of lighting, honestly. Alright, so I want another light now, so let me add this light. And as you can see, as soon as I add the light, you can see it's being taken into account. So this is more of a white light, right? So this is like a spotlight almost. So let me go ahead and change this to a green light so we can get that color mix going. Change it to a green light, and I'll lower the intensity of that a bit. So now we've got light mixing. We've got green light hitting the face, and we've got purple light hitting the other end of it. And yeah, if I go ahead and rotate the monkey a bit, You can see that lighting update. I can scale the monkey up if I need to. Still got some work to do with the face culling, but that's okay. And there are other meshes. Let's go through some of the meshes real quick. So this one here, this is actually the GitHub Skyline model. I exported it and then re-imported it into the engine. So as you can see, that's rendering pretty decently well. Next one would be just a cone from Blender. You can see I've got my lights set up to also use that, just so I know where the lights are in the scene. And then what's this last one? This last one is just a smooth shaded icosphere from Blender. So nothing too fancy about that. It's just, yeah, a smooth shaded icosphere. Like I said, the monkey is really the best showcase of like lighting and everything because it just shades so well. And of course, this is all real 3D. This is a perspective projection matrix. The back of the monkey is not lit. The back of the monkey is just getting ambient lighting. Say we want a little more ambient lighting. The background doesn't correspond with it, so you can see it's a little funky there. But there we go. It's almost a little too white. I personally like taking the ambient light down a lot and playing with the dramatic effect of the point lights. So yeah. Pretty sweet. So yeah, if you guys have any questions about how I did this or how I implemented this, or you have any questions about the metal utility library I created or any of the such, feel free to leave a comment below. Some of the other miscellaneous features that are included in the metal utility library, so you can choose what GPU to render on. So if you've got a trash can Mac Pro like me, you can actually choose to offload the entire engine onto the second unused GPU. That's huge. Unity doesn't even let you do that. The other thing that comes with that is that on your MacBook Pro, if you need to restrict it to your Intel graphics or your AMD graphics, you want to force it one way or the other, you can do that. Obviously, if you're on an M1 like I am right now, then there's no point. You only have one GPU. But yeah, on a multi-GPU system, that is honestly huge. Did I mention that all this runs on the Vita too and looks exactly the same? Like I said, if you guys have any questions, let me know. Otherwise, peace out.